academics?
From academic.
Okay.
Either they have done their PhD or they are on the verge of completing their PhD.
Okay. Okay. Thank you. So 3 days workshop. Let me share the poster first. Just a minute. Okay, so what we are going to do, we are going to do like these three things. These are the three pillars of structural equation modeling using the SPSS and AMOS software. I hope, I guess, like everyone has this software. So EFA and reliability analysis will be done today, day 1. Okay, day 2, that is tomorrow, we'll be doing confirmatory factor analysis and convergent discriminant validity as well as model fit values. Those things will be doing tomorrow. So tomorrow we'll be starting AMOS. Today we'll be doing SPSS. Okay. And day 3 will be testing hypothesis for direct relationships using the path analysis, for indirect relationship or mediating hypothesis. Okay. As well as we'll be also testing the interaction effects and multi-group effects, that is moderation analysis. So I have shared the data sets, some data sets and some models and my PPT presentation, whatever the presentation is there, that is already being shared with the host. Okay. So you can get it from her.
So I've
Now I'll
already
just
shared it to everyone in the WhatsApp group as well as that mail.
Okay. Okay. Has been shared with you also. So so let's start from the EFA. So basically, structural equation modeling is this is the latest or second generation statistics. Okay, and first generation statistics we defined by regression analysis. Okay, so regression analysis was like 10 years before. We used to do a lot of regression analysis, but in last 10 years we have seen massive growth of structural equation modeling. Because the structural equation modeling does not only provide the results, it also provides, it also meets a lot of other criteria that makes the model more robust, more more meaningful, and also you have to fulfill some indices that is not available in the regression. So because of this reason, structural equation modeling has become very popular tool for today's research. Okay, nowadays research, structural equation modeling play big role. Okay, and mostly used in the discipline of business, management, economics, social science, okay, psychology, health sciences also we use it. Okay, so mostly in these disciplines are used. Okay, so yeah, that is about the structural equation modeling. So structural equation modeling, in order to run the structural equation modeling, there are certain softwares available in the market. So one such software is AMOS. Okay, that belongs to IBM family, IBM SPSS AMOS. Okay. Besides that, there is also a software called Smart PLS. There also we can run. Okay, we can also run with using the M plus, SAS. Some other software are also there. Okay, so we can use certain software to run the structural equation modeling based analysis. So for any research, any social science based research, mostly what we do, mostly we create a questionnaire. We either using the previous scales, adapted scales, or developing new scales. We create a questionnaire, and then we then we that questionnaires we circulate to the respondents, and respondents fill out those questionnaires either using the internet approach, online method, or using the physical form like pen and pencil method like hard copy. And then those responses are collected, then they are like purified, and then they are analyzed. That is what we mostly do in the research. Okay, so in that process, what we are learning in today's session is about the like once you have collected the data, what to be done. Okay, analysis part. Okay, so what are the things you should do in the analysis? Okay, so the first thing, you are supposed to check the factor structure, or you are supposed to confirm the factor structure. Like you have to check the scale, validity, and reliability. Okay, before you go for the hypothesis testing. before before you perform the hypothesis testing, you are supposed to check the reliability and validity of the scale. Okay, so reliability and validity of the scale are determined or are checked by two particular analysis. Okay, so called EFA and CFA. EFA stands for exploratory factor analysis, that is done using the SPSS software. There is another technique called CFA, confirmatory factor analysis, that is done by the AMOS software. AMOS, M plus, Israel, these softwares are used. Okay. So, so there are two opinions again here. Okay. One school of thoughts, they say to assess the validity or reliability of the scale, you need not be testing EFA. Directly, you can test the CFA because you are using the previous scales. Already those scales are established. You are adopting the scale. There is no point of performing EFA. Okay, so that logic is also valid. As well as the other group said, no, you are supposed to test the scale. You are supposed to validate, or you are supposed to get the reliability and validity score for the scale, even if you have used the past scales. Okay, so that approach is also there. So if you are a PhD students, then you follow your university norms, rules, practice, whatever the methods they are using. You have to go abide by that, because they are ultimately they're going to give you the degree. If you are a researcher, then it's I leave it to you, your judgment. So for the sake of learning, we'll be learning all the techniques. Like we'll be learning the EFA, we'll be starting with the exploratory factor analysis, then subsequently confirmatory factor analysis, and then we'll be moving on to the hypothesis testing. But the one rule is clear. In one point, everybody agrees that you must assess the validity and reliability of the scale before you run the hypothesis testing. This point is valid because whether you are testing EFA or CFA or both, CFA is must. Okay, at least CFA you have to test, or combining with the EFA. One of the CFA, either you have to test. Either you have to run the CFA analysis, or you can run EFA and CFA both. Okay, that is clear. Okay, at least CFA you have to run. Then you test hypothesis. Okay, then you test mediating moderating. Like that's the procedure. Okay, so step one is that either you run EFA and CFA both, or at least you run CFA. So we learn both EFA and CFA. Then we'll be learning the hypothesis testing. Okay, so the slides you see on the screen, that is the model we are going to actually test. We are going to use. I have the data I have shared is about this model. So in this model, if you look at this model, so what do you have? So this is playful is our independent variable. Okay, this is our independent variable. All right. Okay. Then we have just a minute. This is our independent variable. Okay. Then we have we look at here. This is our. I'm sorry. Sorry. This is our better. I'll highlight. So in this model, what do we have? This is our one of the dependent variable. You can say. Okay. Basically, this is our final dependent variable. So, like say two dependent variables. Let's say that. Okay, and then we have this mediator. We have two mediators here. Okay, and then we have this this experience is like moderator. Anxiety is another moderator, and there are two control variables here, age and frequency. Okay, so this is what we have here. All right. So this is the model we are going to test. Okay, maybe moderating is not possible because I think I don't have that data for this moderating data. I'm not sure whether I have it or not, but other things I have it. Okay. So what is this model about? This data about? This data is about basically collected in the US, in the US university. These they were the students. These guys are the students. Okay, so uh, they like completed their plus two, like 12th, and they have gone to the university for pursuing the undergraduate programs, and they have been asked about their Excel uses. The Excel software, since when they have been using, whether they enjoy it, whether they like it. A lot of questions related to that. Okay, so those questions were asked, and they have responded to that. So most of them are like between 18 to 20, 24, 25, like that. These are the teens and undergraduate students. Okay, so this model we're going to run. If you look at SPSS, so what SPSS does basically, so SPSS, we have like three types of scale. One is nominal scale. This is used for grouping variable. Okay, this is used for grouping variable. Okay, then we have this is grouping, means like either you have like gender group, like we have two gender groups like male female, like it can be either like two categories, categorical variable, or it can have multi-categorical, like race or religions, like it has more than two categories. So whatever it is, whether two groups or more than two groups, okay, that can be measured using the nominal scale. Then we have this ordinal scale. Okay, ordinal scale basically it's like a Likert scale items, where we measure using the strongly disagree to strongly agree. Like this way we measure. Like strongly disagree, if I say 5, and then strongly agree. Sorry, strongly disagree is 1, and strongly agree is 5. That means this way we can measure. Okay, so it has an order. Okay, and like uh, what kind of concept or construct we can measure? We can measure like uh, constructs that are more abstract in nature. What do I mean by that? Abstract means like the construct that you cannot measure directly. Okay, you cannot measure it using the one statement. So you need to have multiple statements to measure those constructs. So such as customer loyalty or service quality. Service quality, if you are aware, it has like 22 items. So if you want to measure a service quality of an organization, there are 22 items under this construct. Okay, so those construct usually we measure using the ordinal scale, such as Likert scale: strongly disagree, strongly agree, never like it, always like it, never agree, always agree, like that. Okay, and it need not be 1 to 5, it can be 1 to 7, 1 to 10, 1 to 3 also. Okay, and finally we have something called this scale, which is combination of both interval and ratio. Okay, so interval scale has exact numerical values, and ratio scale gives you proper ratio. So suppose if I say the temperature of Chennai is today 40 degree Celsius, and the temperature of Delhi is say 20 degrees Celsius. So I can tell that there is a 20 degrees difference between Chennai and Delhi. But I cannot measure that I cannot say that Delhi is twice cooler. Sorry, Chennai is twice hotter than Delhi, or Delhi is half cooler than Chennai. We cannot do that using the interval scale. But we can do this kind of measurement using the ratio scale. Suppose if I say somebody's weight is 40 kg, another person's weight is 80 kg, and we can very well tell that 40 kg person is half lighter than 80 kg person, or 80 kg person is the twice heavier than the 40 kg person. So that kind of measurement is done using the ratio scale. Okay, there's a little bit about the scales. Now we'll go to exploratory factor analysis. So exploratory factor analysis, these are the things we're supposed to check basically. This is done to check the explore the factor structure, and also sometimes we call them dimension reduction. It actually reduces the number of unnecessary unwanted items. Okay, and also yeah, that is the best thing about the EFA. So what do you look at EFA? When you run the EFA, you look at KMO values. KMO stands for Kaiser, Meyer, Olkin, like there were the three statisticians, and the threshold is 0.7, greater than 0.7. Okay, then you look at extracted commonalities, don't go by 5, greater than 0.3. Sometimes it is difficult to fetch this, so we're not going. See, we're not going with the strict conditions. If we have like liberal approach, okay, or the approach that allows us more freedom, we're supposed to take that, not the strict one. So here also total variance, I'm going with this 50% or more. Okay, and non-redundant residuals less than 15%, 50% is acceptable. So if all these four things together confirm or assess the adequacy of the scale. Okay. Then KMO, yeah, here. And another thing I think was not mentioned here, I'm sorry, Bartlett's test of sphericity. It has to be actually, the p-value should be less than 0.05. So this is, usually you get it less than 0.05. This is what we're supposed to test it here. Okay. Sorry, I'm sorry. So when you run this analysis, okay, somebody asking a question. Now this is not normality. Normality is, I was not talking about normality. I was talking about EFA. When you run the EFA, what are you supposed to know? A pattern matrix, when you run the EFA, KMO stands for Kaiser, Mayer, Olkin. There were three statisticians. So it's called sampling adequacy, not normality, whether the sample was adequate or not. So if your KMO value is greater than 0.7, it means you have adequate sample. So if you look at the that here, this is our pattern matrix. Okay. So pattern matrix, there are two rules regarding the pattern matrix. Rule number one, the loading must be greater than 0.5. Okay. Loading must be greater than 0.5. That is the rule number one. Okay. If that is achieved, along with that, if you notice here that ST values loaded onto ST. Similarly, as ST value 2 also loaded onto ST value. So all three loaded onto the ST value, this particular factor. Okay. And also all the loadings are greater than 0.5. So what it means? It means that we have established the convergent validity. Okay. Here also loyalty 1, 2, I think up to 3. Yeah, they actually loaded onto the same factor and loading is also greater than 0.5. That means we have established the convergent validity. Okay. But here there are some problems. Okay. So we have like cross loading, but there is a rule for that. If the difference is greater than 0.2, okay, then you need not
Okay,
be
sir.
deleting it.
Excuse
Need
me,
not be
sir.
deleting. Yes, yes. Yeah, yeah.
Sir, I think people will be having problem in understanding this because if it will be better if you can give some premise of this, why we are doing this calculation and what was the main question from where these calculation arrive. Like if you can show from the database and how it.
No, no, no. I'm going, madam. I'm going to run the data, but before that, I
Okay.
just wanted to talk about it. I've given all the data in order for that purpose only. So just
Okay,
this
sir,
is
okay.
like a little bit, intro. So if I just go directly with the data again, they may have questions. Okay. So
Okay.
this will go with the data only. Okay.
Okay, sir. Okay.
I'll
Okay.
be running the data. I'll be doing this analysis just in a while.
Sure.
So okay, so here in this case, so there are two opinions. You see, there is a cross loading like between 0.2 and 0.7. So one opinion is that you can delete it. Okay, if you think like this is becoming a problem. But another opinion is that they say if the difference is like uh, less than 0.2, then only you delete. Okay. Okay, if the difference is greater than 0.2, that means their difference is high. So like here. Okay, so we can also keep it. But the problem is here, they should have loaded this side, but instead they have loaded that side. Okay. So this means this loyalty 4 to 7 may not be the same loyalty what you see 1 to 3. It may be something different factor. You can take this score, you can ignore this score, okay, and you can call it like loyalty to different types of loyalty. Like this, you can call this like behavioral loyalty, and this one you probably call it attitudinal loyalty or something like that. Okay. But loyalty 8 we have to delete. Why I'm showing this? Because basically the data I'm going to run may not get this kind of situations. Okay, but here these situations are there. So loyalty 8, if you look at here, we have no option but to delete, because the rule says if the difference is less than 0.2, we should delete it, because they're almost same thing, not difference. Okay, so better we delete it. Okay. Others are fine. So convergent validity established if the loading is greater than 0.5 and the fact and the items loaded onto the same factor, that is convergent validity. Now there is something called discriminant validity. Okay, that means, what is discriminant validity? If there is no cross loading, there must not be any cross loading. Okay, okay, high value cross loadings. And also another factor, if you look at here, okay, interfactor correlation or inter component correlation, this matrix, if you look at, either you can look diagonally the bottom part or the upper part, it is the same thing. If the correlation between the factor is greater than 0.7, that means we have discriminant problem. That is not a good thing for us. Okay, so the correlation is required less than 0.7. What is the logic behind it? The logic is that if they are highly correlated, that means they are the same thing, they are not different from one another. They have to be different from each other, discriminant, distinct. Then we can call it, no, they are separate, different factors. Okay, so high correlation is not expected in the factor correlation matrix, and cross loading is not expected. Okay, and finally, for reliability check, we use Cronbach's alpha value. That ideally we say it has to be like, greater than, like it is already given, greater than 0.7. Okay, so this is what we check, Cronbach alpha value. Even greater than zero point 0.6 is also acceptable. Okay, but less than 0.6 is not at all acceptable. This is acceptable. Okay, please remember that. Okay, this is ideal. Greater than, if you have like greater than 0.7, this is ideal. So if you're running EFA, what you're supposed to check? You're supposed to check these things. Okay, so you have to check the adequacy. Okay, sampling adequacy. You have to see, make sure that Cronbach alpha is greater than 0.7. Okay, greater than 0.7. Okay. Number two, I'll answer the questions, whatever the questions you have put, just give me 2 minutes. I'm almost done here. Okay. Then discriminant validity, you have to check if the difference is less than 0.2, then delete the lowest one, lowest value. Okay. Negative, okay. Convergent validity greater than 0.5. Okay, less than 0.5, we have to delete. Okay. Reliability 0.7, greater than 0.6 is okay. Okay. Okay, this is what we are supposed to do. So this much was about the little bit background about the EFA. Now we're about to run the EFA. Before that, yeah, I've just said, I think you still need clarification, Mr. Singh, or you understood what I tried to say. Convergent and discriminant validity. You still need clarification, or you understood?
Understand,
Just
sir.
I understood. Okay. Okay,
Yes.
okay, ma'am. Okay. Now please open data. That data I have already shared with you. Sorry. Please open that data. Now we're going to run the analysis. Okay. Open. There is something called clean data set, EFA. There is something called clean data set. Please open that data. Tell you which data. I'm gonna take all the data. Yeah. You use the folders what I have shared with you. Okay. It's called clean data set, clean underscore data set. Please open that SPSS data file, clean underscore data set. Mine is opening. If you have opened, please write O in the chat box. Have you opened this data set, clean underscore data set? If you have opened this data set, please write O in the chat box. Guys, did you open the clean underscore data set? Okay. What about other people? At least 3 years I want to see. One more yes. Okay. Okay, shall I run it? Okay, let's run this. So what we have to do, all of us, please go to analyze from here. Go to analyze, then go to dimension reduction, then go to factor. Analyze, dimension reduction, factor. You have to click factor. So please click factor. Okay. After clicking factor, you have to select from playful 1 until decision quality 8. All the items you have to select. Starting from playful 1 until decision quality 8. All are Likert scale items. Please select all of them. Then send it to the right side of the empty box. Can you see the right side empty box? Using the side arrow, we can send it to the right side. So please send all the Likert scale items starting from playful 1 until decision quality 8. After sending them here, a couple of tabs we have to open and we have to give some kind of, we have to select some options from there. So first one, the first menu supposed to open is descriptives. Please open descriptives. Under the descriptives, just check the KMO and Bartlett's test of sphericity box. Only the last that box. KMO and Bartlett's test of sphericity. You can do a lot of things. You do not need everything to be done here. Just check the KMO and Bartlett's test of sphericity. Then continue. Click continue. Extraction. Please click extractions. There are several extractions methods in the EFA. Just a moment. Okay, so out of that, if I click the method, there are 7 available in the SPSS. Out of 7, principal components, maximum likelihood, and principal axis factoring are the popular ones. Okay, of the 7 methods, these 3 are the popular one. So default is principal component. So I'm going to keep the default. So I'm not going to change anything here. If you look at the extraction methods, we can extract factors based on the eigenvalue greater than 1, or we can also extract factors based on the number of factors we want to extract. So the default option is based on eigenvalues greater than 1. We are going to follow this one. Okay, we are going to follow the eigenvalues greater than 1. Then click continue. Okay, so we kept everything default. We did not change anything in the extraction method. Now you go to rotation method. Please click the rotation method tab. If you look at here, also you have like 5 different methods: vary max, direct oblimin, quality max, equa max, and pro max. Out of that, vary max and pro max are the popular one. Vary max is called orthogonal kind of rotation, where pro max is called the oblique rotation. I'm gonna go with the pro max. We're gonna go with the pro max. Okay, and do nothing here, just continue. Okay, scores, we need not be going by the scores. Okay, after the rotation, click the options tab, options menu. So if you look at the options menu, what do you see? You also see there are certain things we can do here. So this square box called suppress small coefficients, absolute values below 0.3. Okay, so make it 0.3. Guys, keep 0.3 here. Continue. So we have made the necessary adjustments. Now we are ready to run the analysis. Okay, now we have to only click OK, hit OK button. Okay, so once you hit the OK button, you'll get this output. Okay, did you run with me? Did you guys run with me? Were you able to run the EFA by yourself? If you have run EFA, write EFA in the chat box. Exactly the same EFA what I did. Meanwhile, I explain you what this means actually. So here, if you look at this, this one, 0.9. Okay, 0.91. Okay, this is our KMO score. Okay, all right. And this is our Bartlett's test of sphericity. The p-value has to be less than 0.05. KMO has to be greater than 0.7. So it is greater than 0.7. So we are good. If you look at the extraction, these values, no, they are all like greater than 0.3. Okay, all are greater than 0.3. So this way we are good here. Or greater than 0.3. Now total variance explained if you look at here. Okay, here how to know that what is this percentage? You have to look at here 68. Okay, how do I know this one? If you look at eigenvalues here, eigenvalues greater than 1, right? So eigenvalue greater than 1. Here whatever is loaded, that one we have to do, and we have to look at cumulative scores of 68 percentage. 68 percentage. So 68 percentage is greater than 50 percentage. Okay, so total variance explained 68 percentage is a good score. It's a good score. Okay, so we have the total variance explained is also good. This is a useless matrix. Okay, components matrix, pattern matrix. Now look at the pattern matrix. Yeah, if you look at the pattern matrix, please look at the factors. So what happened here also? If you look at this play pool 1 to 7, all loaded onto here. All the items loaded onto the same factor, and all the loadings are greater than 0.5. Similarly, anxiety 1 to 7, same story repeated here. Same story repeated there also. So everywhere, if you look at the loading is greater than 0.5, and they loaded onto the same factor. Okay, they loaded onto the same factor. So what we establish convergent validity. Okay, the internal consistency. So what happens in the convergent validity? That item to item correlation must be high. They must load onto the same factor. What is discriminant validity? Discriminant validity means factor to factor correlation should be less. They should be different from each other. Okay, so convergent we established. Now what about the discriminant validity? Do you see any cross loading here? You don't see any cross loading here. Okay, so that is one of the criteria of discriminant validity. There is another criteria that is called, this matrix also useless, structure matrix we don't use. Another criteria is that component correlation matrix. If you look at the component correlation matrix, you can see that the interfactor correlation is less than 0.7. Okay, is then all of them are actually less than 0.7. This is also less than 0.7. This is also less than 0.7. This is also less than 0.7, 0.7, 0.7. So what we did actually, we established the discriminant validity. So we established the convergent validity as well as the discriminant validity in the EFA. Clear? Do you have any questions here right now? So this data was a great data, very easily we got everything done here. Okay, but every data may not look like the same data. you may face difficulty. So what to be done with those data? Okay, so for that purpose, I have shared another file name called Messy EFA. Messy EFA example. Messy underscore EFA underscore example. Please open that file. So it's a problematic EFA, and we'll try to sort out the problems. We'll try to resolve the issue. Okay. All right, guys. So you open the Messy EFA, and after opening, we're going to run this analysis. Okay. This I have a little bit cooked up this data, fabricated data actually, for the purpose of showing you if we get problems, what to be done. We'll run it in the same manner what we have run the EFA model first. Okay. So you have to go to analyze. First, you have to go to analyze, and from there, you're supposed to go to dimension reduction. Then you go to factor. Again, you're going to select from a playful 1 until decision quality 8. All these items, send it to the right side, and you're going to perform the same analysis what you have done just now. Descriptives, you choose the KMO and Bartlett's test of sphericity. Continue. Go to extractions. We're going to follow the same default method here. Then you go to rotation. Rotation, we're going to select Chromax. Okay, continue. Then you go to options. Options, you go suppress small coefficient. Absolute value less than 0.1, make it 0.3. Okay, continue. All right, then click OK. So we have run this analysis. KMU is okay, it's greater than 0.7. We have no issues with that. Bartlett's test of sphericity is also less than 0.5. We are good at here. Communality is also greater than 0.3. So I think we don't have any issues here also. If you look at the total variance explained, that is like, we got like 75%, 75.278. So this is also good. No issues here. This is not a useful matrix. Now, if you look at the pattern matrix, we got some issues here. Okay. So first of all, what you see that, we open this pen actually, so I can show you. Yeah. So if you look at this score, so if you look at playful 1, so the problem is here and the problem is here. Okay, so there are two problems in the same row. Now, so we have like two problems. So problem number 1, the low loading. The loading is less than 0.5. At the same time, there is a cross loading, which is like greater than 0.5. So two loadings on the same place. The rule is we cannot keep this item. So we're going to delete this item soon after, like, once we understood all this, pattern matrix, we're going to delete them. Okay. Now, the second one, if you look at, that's fine. Anxiety looks good. Useful also looks pretty good. And if you look at compuse, let me clear my drawing. If you look at compuse, also good. Then info acquisition 2, there is an issue with the info acquisition 2 here. Okay. So it is like 5.88. Okay. So here even the difference is like 2. So you probably can keep it. You follow one school of opinion. Okay. If you follow another school of opinion, then delete. Okay. So we'll see. Okay. I'm gonna actually delete. Okay. I don't care whether the difference is 0.2 or not. So I'm just gonna delete. Okay. I still have sufficient items. The decision quality 8 is also cross-loading. Again, you can keep it or delete it, because if you follow 0.2 rule, then you better keep it. If you don't want to follow 0.2 rule, better delete it. Okay. Then you go to decision quality 8. I think we have to delete it. We cannot keep it because the difference is anyways less than like 0.2. Now, decision quality 8 is a loaner. Somewhere else you just load it. So this is also cross-loading. This is cross-loading. This is cross-loading. This is cross-loading. Also, this is cross-loading. Okay, there are multiple cross-loadings. Okay. What I'm gonna do it, I'm gonna delete them. Okay, I'm gonna delete them. And I'm gonna see what happens. Okay, so I'm gonna delete the first one, playful 1. So I'm gonna delete the first one, deleted. First one deleted, and then I go to the info acquisition 2. Info acquisition 2. Where do you see? Yeah, this is info acquisition 2. You delete that. Then you delete the info acquisition 5, another loader. Info acquisition 5. You delete that also. Then you delete decision quality 2. Okay, then you delete decision quality 6 and decision quality 8 probably. Okay. Yeah, these you're supposed to delete. All right, then after that you go to rest is fine, just click OK. Look at here now, again it's 0.803, that's good, less than 0.007, here also greater than 0.3, all of them. If you look at here, the 6 factors loaded onto 73%, this is really remarkable, this is really good. It's not a useful matrix. Yeah, pattern matrix, if you look at this side is fine, all the playful items loaded onto the playful factor, all the anxiety items loaded on the anxiety factors except this one. It is like, we have like one negative loading, another is positive loading, like that. We'll talk about that later. Okay, and then we have all the computes loaded onto the compute factor, all good. In fact, it is 134 really. Okay, here is a problem. Okay, where is the problem here? Actually, major problem is not there. Major problem is, yeah, this one. Okay, there's a cross loading. Okay, right. So here is a cross loading. So we have to delete this also. Okay, we're gonna delete all of them and then we're gonna see. So like we have to delete 2 now. Okay, one is anxiety 7, another is infatuation 4. So anxiety 7 and infatuation 4. Click OK. All right, now it's 0.91977. That's good. Greater than 0.9 is okay. Greater than this is greater than 0.3. All good. Here it is 75%. Now you see. Commonality is good. Okay, total variance explained good, 75%. Pattern matrix. Do you have any problem here? Here? No, all perfect. Okay, you cannot go beyond 2. At least you need 2 items to run the EFA or CFA or convex alpha. Less than 2 is not, you cannot do it. Okay, it will not allow you to run. If you look at component correlation matrix, also they are less than 0.7. Okay, so I've explained you the EFA part, also using the messy EFA data. Okay, so now I want to take 2 to 3 minutes break with your permission, and then when I return, I will start the reliability analysis, and also I'll take questions if you have any. Okay, so just give me 3 minutes break. Okay.
Meanwhile, if you're not running the program, you can run it. You can use your SPSS, download the data, and you can run EFA over there, EFA, CFA over there. And so that if you're having any question, you can ask it to sir.
All right, guys, I'm back. Okay, so you have any questions? Anyone has any questions?
Participants, if you have any
Don't
question, you
have.
can ask it. You can unmute yourself and you can ask directly. So I think we should move ahead.
Yeah,
Uh,
yeah. Okay.
they have not
Okay.
downloaded it. So I just
All right.
wanted to ask you one thing. Why do we do rotation in EFA and like factor analysis? We put rotations, we put eigenvalue. Eigenvalue are understandable, but why? What is the significance of rotation over there?
That's the method actually. That's the way it works. You're saying this one, yes. So like extraction is technique. Similarly, rotation technique is there. Okay.
Extension
So
data
they
is not opening. Kiran ma'am is saying that extension data is not opening.
no. I'm not doing that one now. That is related to the CFA. That is related to MO software. Tomorrow I'll be doing that. So you need to
And we'll
have
be
the MO
doing that
software.
tomorrow, ma'am.
Yeah, you need to have that software for tomorrow for
So there is
opening
another
that sub.
question. How do we check normality of Likert scale?
Okay, normality of Likert scale you can check very well. So okay, before you are asking the rotation, no? So
Yeah.
rotation is a so these are the extraction techniques. Okay, so like
Mm-hmm.
extraction we have this, so we can extract based on this. So similarly, that this is also rotation technique. Okay, so data is extracted and data is also rotated. Okay, if you don't want to use it, you can do that, but it will not give you this results. That's I'm not using this any rotation techniques. So I cannot see that rotation that results will not be there. Pattern matrix or any matrix you want, that matrix it will not produce. Okay, so it will just give you up to this. Okay, up to the
Okay,
total
sir.
variance expense KMO communalities you'll get. But if you want the matrix, pattern matrix or the component correlation matrix, then you need to rotate it. Then only it will be able to produce. Okay. Just say algorithm, just a tool. Okay.
Okay.
Normality, somebody asking normality. How to test normality? There are many methods. So the best method is this one. Using the skewness and kurtosis. Okay. So just go to analyze, go to descriptive statistics, go to frequencies. Okay, go to go from playful one till again decision quality. We check normality for everything, not necessarily Likert scale. Okay, I don't need frequency tables. All the variables you put inside, all the variables. You use all the variables of your data for normality checking, except ID. ID is just like a serial number. I don't want to. It's just meaningless. Okay, doesn't no use of it. Then you go to statistics. There is a tab called statistics. Just click this tab, and under this tab also so many things you can do. We only want to do the distribution. Under the distribution is skewness and kurtosis. Please check these two boxes. So we'll be testing normality using the skewness and kurtosis values. Okay. After checking, continue, click OK here. Then SPSS will produce this table here. Okay, this is statistics table. Just double click this table. Then go to pivot, transpose rows and columns, close this one. So you can visualize better. That was the only thing. That way also you can visualize, no problem with that. So what you have to look at here, you have to look at the skewness value and kurtosis value. Skewness value, this particular column, and kurtosis, this particular column you have to look at. And what you have to look at, you have to make sure that this is less than or equal to 3. Okay, less than or equal to 3, plus and minus 3. Actually, go by absolute value. This may confuse you. Less than positive 3 or greater than minus 3. Okay. But you get confused, just go by 3. So it has to be less than 3. If it is less than 3, that means your data is normally distributed. You achieve the normality. Okay. If it is greater than 3, then there is a normality problem. Okay. Suppose you have 20 variables, 1 or 2 are greater than 3 but less than 5. If it exceeds 5, we cannot keep it. We have to delete that item. So 1 or 2 we can allow 1 or 2, but not more than that. Okay. So this is the best approach. This is the liberal. This is the best approach. Actually, if you use other things, like Sapiro, Wilk, Kolmogorov, Smirnov, other tests, those are very strict tests and very difficult to achieve the normality using those tests. So use the skewness and kurtosis. Use 3. Threshold is 3. If it is less than 3, well and good. Your data is normally distributed. Okay. Another thing they say, if the data is large, usually it is assumed that it is normally distributed. What is large data? Like through 200, 300, 400, 500. These are the large data. Okay. What is this small? Everybody is clear. Like 50, 60 or 30, they are all small. But 61 does not become large. Okay. 61 does not become large. All right. So large data they use one theory called central limit theorem. Based on that also, they say that if the data is normally, see, if the data is large, it is assumed that data is normally distributed. Clear? So you use the skewness and kurtosis. Okay, guys. Yeah, our data is normally distributed.
Sir, we check the normality before performing the CFA or EFA or after
Yes.
that?
Before.
Before. That means first we have to perform the that normality test. After that, we can use the EFA model.
Yes, absolutely right.
Okay. Thank you, sir.
Okay. So one second. Somebody asked a question. I'll take your question. 3. Dr. Kiran, 3. It is 3. Okay. Now we'll go ahead from here. We'll move on to next analysis, that is reliability testing. Okay. So same data we can run the reliability testing. That is the another topic of the workshop, like this one, reliability analysis. So why reliability analysis now? Suppose if you are say this study is different. Suppose you just want to run a pilot study for 30, 40 or 50 data, and then you want to conduct a main study. In that case, you don't run EFA for 30, 40 or 50 data sets. EFA require large sample. Okay. So if you are running a pilot test, then we can check the reliability analysis, and then from there we'll collect main data, then we'll run EFA. That is one model, which is very much existent in India. Another model is that we don't collect pilot sample, that we collect a main sample like 300, 400 like that. In that sample, if you want to run the analysis, then you first run EFA and then you run the reliability analysis. Okay, I think you got my point. Now let's learn how to run the reliability analysis. Please go to analyze. Okay, from the analyze, go to scale. Okay, and then click reliability analysis. Okay, analyze, scale, reliability analysis. Please click this one. Okay, so once you click this one, here you have to check factor wise, not the entire thing. You have to check factor wise or the construct wise. So playful is one factor here. So select all the playful items and send it to the right side here. Okay, then you go to start. Okay, no, need not be going now. Just run it. Okay, just run. Click OK. Okay, so we ran this. Okay, so what is the Cronbach's alpha value? Do you get? It is 0.914. 0.914 is greater than 0.7. Okay, so that is good. We got the good reliability score. Okay, now we'll run for the another one. This is a shortcut method. Okay, you can open it from here. Okay, reset. Again, you click anxiety 1 to anxiety 7. Send it to right side. Okay, and then just click OK. So this time also we got 0.934. 0.934 is also greater than 0.7. That is also good. Okay, we did not face any difficult, like we have good reliability scores. Then you go to, again, you go to analyze, scale, reliability analysis, reset. This time is the, I think this one, useful 1 to 7. You send it there, click OK. 0.941. This is also good. Okay. Then go to reliability analysis again, reset. This time comp use 1 to comp use 4. Right side, say okay. This is 0.819. This is also good. 819. This is also good. Okay. Then you go to next. Compute. After compute, we have info acquisition 25. Okay. Click OK here. 0.839. This is also good. Okay. Then you go to reliability analysis again. Again, this time you take decision quality 1 to 8. Again, right side. Again, click OK. 0.904. This is also good. Okay, so we got all the reliability scores for the 6 constructs, and we got all above greater than 0.7. Okay, that was a great score. Okay. Now this was really good data. We got it like that. So suppose if you get problems, like if you don't get good loadings, how to fix it? Okay, if you don't get 0.6, even if you don't get 0.6, you get 0.34 or 5. So how to fix that reliability score? There is a technique for that. So for that purpose, I have given another data set. Is called low alpha value, low alpha example, SPSS data set. Please double click, open this one. Low alpha example. Please open this. Okay, this is just I fabricated for you for your purpose. So just go to, and only we have like 10 samples. Okay, go to analyze, go to scale, go to reliability analysis, and then you just select the problematic one. Okay, select info acquisition 1 to 5. Okay, info acquisition 1 to 5. Click here, right side, click OK. What is the Cronbach alpha value do you get? Did you get 0.484? Please let me know in the chat box. Did you get 0.484? Yes, okay. So 0.484 is not at all acceptable. It is way low, very low. Okay, so minimum is 0.6. So what do we done? So there is a technique available in the SPSS for this purpose. You go to analyze again, go to scale, go to reliability analysis, and then you go to statistics here. Okay, and there are a lot of options here. We're just gonna select this one. Please check this box. Scale if item deleted. From the top, from the top left, there are like descriptives for in that. Scale if item deleted. Please select this box, continue, and then click OK. Okay. So once you click OK here, you can see that it gives some suggestions. Okay, like it says that the last column, you have to look at this column. Cronbach's alpha if item deleted. So suppose if you delete the first one, you'll get 0.309. It's not helpful. If you delete the second one, you'll also still get 0.367. Not helpful. If you delete the third one, you'll get 0.479. It is not helping you. Fourth one, 0.226. But if you delete the last one, you'll get 0.616. Your problem solved. Okay. So let's read that one. Go to analyze, scale, reliability analysis, and delete the last one. Like remove it from the list. Just to the left side. Click OK. Now we got 0.616, right? So 0.6 is acceptable. 0.6 is acceptable. Okay. So our goal is not to delete as many items as possible. Our goal is to retain as many items as possible. Our goal is to retain the items, not the deletion of the items. Okay, retaining of the items is our goal. Okay, because there are subsequent analysis where we would tend to lose more items. Okay, now I will probably stop here, but for the curiosity purpose, and if you want to know what is the maximum Cronbach alpha value, you can get it using this technique. then we'll go by this. And if you look at the third one, info aggregation 3, it says if you delete this item, you'll get 0.695. So let's do that. Go to reliability analysis and delete the third one. Okay. And then see how much you get. Okay. Click OK. You get 0.695. You want to know further what scores you get? If you look at here, if you delete the number 2 items, you get 0.805. So delete it. Okay, delete the 0.2 items and then check. Yeah, we got 0.805. You cannot further delete because you cannot run Cronbach alpha for less than 2 items. Similarly, you cannot also run EFA with less than 2 items per factor. So you need minimum 2 items to run, because if there is no correlation, we cannot run either EFA, either CFA or CFA or reliability analysis. Okay, so we got 0.805. So you need not be deleting this much. You better stop here, 0.616. Okay, that was just for the learning purpose. All right, so that with this we conclude the reliability analysis. Do you have any questions, guys? Or if you want to share your data, or if you want to run your data, we can do it this now. EFA. You can unmute yourself and you can talk to us.
Do you have any questions on this?
You can share if you have problematic EFA or EFA or like reliability issues. You can run the analysis right now. Solve your problem. Because the number of participants are very small, so we can do these things, you know. So it's an opportunity for you guys, but
Hello, sir.
yeah.
How much acceptable moderability and acceptable and moderate reliability of its value more than 50% or?
Excuse. Yeah, go ahead. Go ahead. Somebody adjust. I request others to mute so we can hear that person properly.
Yes.
This is coming from your house only. Now go ahead, Mr. Adane. Hello. You wanted to ask a questions? Please go ahead.
Mr. Shruti, you can ask your question. I think that he has moved to some moving to some silent place.
Mr. Eshetu, Adane. Questions?
So Mr. Shruti is from Ethiopia.
Okay.
Yes, ma'am.
Yes, sir.
Yeah, go ahead.
Yes, sir. You had
Yes. There was a connection problem.
Yeah.
My question was, how much acceptable of reliability standard? That means
0.6.
how much the standard?
Yeah, standard is 0.7.
Okay.
Suppose how it works, I'll tell you. Like suppose I have 6 constructs. Okay, 6 variables, 6 constructs. So out of 6, 4 are expected to have like greater than 0.7. 2 can be less than 0.7, but at least 0.6. Less than 0.6 is not acceptable at all. Okay.
Okay, sir. Okay.
All right. So I think if you have no questions and if you don't want to run your data analysis for the EFA, so it was an opportunity for you, because usually we have large number of participants. It doesn't happen. So we can go further. We can go for the next topic. Okay. That is confirmatory factor analysis. All right. So confirmatory factor analysis basically the same thing, like you see this is EFA, the left side you see, no, this is EFA. Okay, So exploratory factor analysis, and the same model we built in the confirmatory factor analysis using the MOS. Okay, same model we built it here. Okay, so this works a little differently than the previous one. Okay, here we get like matrix like this, but here, like, we connect the arrows and from one construct to the, these are the observed rectangle shape observed variables. We actually call them observed variables, and this is like unobserved. Shapes also mean something like that. So they looks like that. We also have error terms which was not available in the EFA. Error terms were not there in the EFA, but here we have the error terms. And then these are the loading scores. These are the loading scores like what you see here. These scores are here displayed here, and these are like correlation or covariance. If it is raw form, we call it covariance. Standardized form, we call it correlation. So these are the values. So even here also the rule is like, you must not correlate high. So here that is like 0.8 or 0.9 sometimes. 0.8, it goes from 0.8 to 0.9 depending on the context. Okay. So we'll change this data to EFA. Okay. So this was just an overview of the EFA. We will change this data from EFA to CFA. Okay.
Sir,
And yeah, go ahead.
hello.
Yes,
Sir, this correlation shows the same discriminant validity.
yeah, it will be similar to that. Yes. High correlation
So,
means you face discriminant validity problems.
okay.
Better to
So,
have
right. So in CFA, we need not to go for the CFA, the conversion validity and discriminant validity.
we'll be doing that. Very much we'll be doing that.
Okay.
CFA will be doing that now. Okay. While running the model, you'll see that. Okay. Now I'm just giving a little brief, like little background about that. Okay. It's a part and parcel. See, any factor analysis, we have to have at least two types of validity. One is convergent validity, another is discriminant validity. Without that, it is meaningless. What is convergent validity? Convergent validity, we want to see the items that belonging to the factors loaded onto the same factors. Okay, that is the part of that factor. That is what we are testing in the convergent validity. Discriminant means one factor is different from the another. Okay, so one place we want all the items to be related to each other, loading into the same factor. Another side we want to know that this is different from that is. Okay, so this is like this. Like British people, whoever has British citizens, they should be British. They should belong to British, right? But Indian people belongs to India. But India and Britain is not same thing, right? They are two different countries. If they are the same country, then they will have same name, not Britain, not India, or like either Britain or India, right? Similar to that. Okay, so risk is not pressure, and pressure is not risk. Mindfulness is not safety, and safety is not mindfulness. That is discriminant validity distinction. Okay, but whatever belongs to mindfulness, that must load into mindfulness, not into the safety. Or whatever the items belong to safety, they must load onto safety, not mindfulness. So this is like a test. Yeah, this is the way they tested the statistics in this analysis. Okay, here also like higher than 0.8 is not good. Just now I was talking about that. Okay, second order structures, I'll talk about that. Basically, what we have, some constructs are unidimensional. So, okay, we call it first order. Some constructs, not constructions, some constructs are or factors are multidimensional. Okay, so there we perform second order structures like service quality, there are many factors like that. And you want to test human intelligence just based on one subject. Can you determine the human intelligence? No, you have to test it multiple things. How good in writing, how good in maths, how good in thinking, reasoning, all those things. Then you can tell, right? Okay, so what you have to test here also, we have to test AVE. It's called average variance extracted. Okay, the rule is it has to be greater than 0.5. Okay, I think somewhere it is written. Okay, greater than 0.5. And how we calculate that, basically you see the factor loadings. So it is squared, all are squared and added and divided by the number of factors, a number of indicators. Actually, here we call them indicators. In SPSS, we call them items. Okay, here we call them indicators. Okay, in this software. So they are squared, they are added. Okay, and then they are divided by the number of indicators. Okay, here 4. That value is your ABE, similar to here also. Okay. So ABE, if ABE is greater than 0.5, and there is something called composite reliability, which is equivalent to Cronbach's alpha, which is produced from from the SEM model, from the conformity factor analysis. This also has to be greater than like 0.7. Okay. If two things you establish, if these two things you achieve, you establish convergent validity. Here, how to establish convergent validity using the AMOS software confirmatory factor analysis. The ABE must be greater than 0.5, and the composite reliability, which is like a Cronbach alpha value, that has to be greater than 0.7. Even greater than 0.6 is also acceptable. Okay. Then we establish convergent validity. Then how do you establish discriminant validity? Establish discriminant validity using this technique. It's called like, like you remember we have squared them, we have added them, and we have taken the average of them, and we have called them AVE. Now you have to square root it. Why you have to square root it? Because if you square it, if you take the root of it, then you'll get the original score. Otherwise, it's an inflated score, isn't it? So you square root it, you take the square root of it, and then you compare with the interfactor correlation. So the rule is, if the if the square root of the AVE is greater than interfactor correlation, then we establish discriminant validity. Otherwise, I'm telling, if the interfactor correlation is less than the square root of the AVE, then we can establish the discriminant validity. While I run it, then you'll get better idea about it, clarity about that. So can you please explain the uses of CF and EFA? What are the difference among them if they both are used to measure the convergence? Yeah, they measure in their own terms. There are different methods. In layman language, I'll tell you, like suppose you want to know your weight. Okay, you want to check how much weight do you have, like what is your weight. So you have a non-electronic measurement scale, like you have manual scale, old is like 30-40 years old scale, analog, and then you have the digital scale. Okay, both can check the measure, but if you check both the scales, then you can tell that your weight is, it is more valid, isn't it? Less biases. Okay, suppose you use one scale, that measurement is correct, I'm not denying it. Okay, but multiple times. Okay, suppose you have blood pressure machines. Now we have electronic machines. Olden days, those pumping machines. I'm not going to go to that debate. I'm just using these examples to, just to give you some clarifications in that. Okay, which is better, I myself don't know. Okay, so olden days they used to pump. That technique is there. Also, latest techniques is also there, the electronic one. Both the measurements methods are there. Okay, so like that, these are two different techniques. Okay, two different techniques. EFA is an old technique, CFA is a new techniques, like it's based on structural equation modeling language. Okay, and these are two different things. So if you test your model in these two, okay, so then it has less biases. You have like, oh, you understood. Okay, so there are two different tools. CFA is must. So why CFA is must? Because it is more robust. It has, you have to fulfill more criteria in CFA compared to EFA. Okay, all right, so I do not deny the role of EFA, but CFA is must. All right, I'll try to get some other examples. So this is basically, like let's go back to the weight machines. So if you want to see, human weight is fine. Human weight, there is no problem. I mean, 1 or 2 kg here and there, we don't care. Suppose you want to measure the weight of a medicine, life-saving drug, and you have to give that drug in optimum quantity, no more, no less. Okay, then it will not affect the patient. Otherwise, this may have a severe consequence. So you have to make sure that you are using correct scale to measure that drug. Okay, then you understand the seriousness of the scale. Understood my point? So research is a serious thing. Research is not your personal life. Okay, it's not your personal opinion or personal biases can be tolerated. So like that, we have to be very serious about the scale. The scale you are going to use, yeah, we have to make sure that the scale is reliable and valid before we use it for hypothesis testing or other things. So the techniques for checking the reliability and validity, the scale whether it's reliable or valid, is EFA and CFA. These are the dominant tools in the social science business area. Technique. These two techniques are used. Okay. I hope this have clarified your doubt in that regard. Composite reliability is equivalent to the Cronbach alpha, so the values are also same. And yes, why I was telling it's robust, it is, it is more like dynamic, more, it is like it has more power compared to the EFA, because it's just not you get the results, you also have to fulfill the model fit. You have to achieve the model fit in this. This was not the condition for the EFA. So there are the 4 things you're supposed to achieve using the CFA model. This is called chi-square and degrees of freedom. Okay, chi-square divided by degrees of freedom. This is what you this ratio. It has to be, if it is less than 3 is well and good, less than 5 is also acceptable. CFI stands for comparative fit index. So greater than 0.5 is ideal. Greater than 0.9 is good, acceptable. SMR stands for standard root mean residuals. It's like a kind of error. It has to be like less than 0.08. Okay, if it is greater than 0.08, then it's problem. And RMSEA means root mean square error of approximation, supposed to be less than 0.8. So we have to fulfill these 4 criteria must. There are many other threshold values, but the books and the scholars, they don't say, they don't, those are sensitive to the data. So if you don't achieve those values, no problem, but these 4 you must achieve. Okay, model fit. These 4 is supposed to achieve it. Okay. And finally, while running the CFA, you'll be able to impute the model. It's called data imputation. Imputing the model means you can get the factor scores. If you impute it, it will produce a SPSS data file, new data file with the factor scores. Okay, using the CFA, we can do that. We can do so. Okay. And that was about the CFA. Yes, that's all about the CFA. Now we can. All right. So tomorrow we'll run this. This model will run tomorrow. So today you have like some basics about it. Okay. So tomorrow we are gonna run this model. Okay. So today only that theoretical aspect. So to run this model, like you need to have this Amos software. So we're gonna run all these models. I'll start with the CFA model. This model will run first, then I'll run higher order model and some other models also I'll run tomorrow. And also I'll tell you how to calculate the AVE, composite reliability, all those things tomorrow. Okay. So if you have any questions or anything like that, we can discuss, because we have only 5 minutes left. So I think better we need like half an hour's time for the CFA model. So tomorrow is better. Okay.
So participants, if you have any more questions to ask.
Yeah, or any data if you want me to run EFA, that is also okay now. 5 minutes we can do that. EFA or convex reliability, whatever, convex alpha value, whatever we have discussed. All the data sets have been given to you. Please make sure that you have the SPSS Amos software. Suppose you don't have the Amos software, so I'm going to share one like trial version. Trial version, the problem is only you can use once in a year for a month. So anyway, I'll share with the organizer those links for trial version download. Suppose if somebody has a problem, if your SPSS and Amos is working fine, don't do that. Okay, don't go for that. So I'll just share that thing meanwhile.
Or you can also like utilize a cracked version, you can use a cracked version.
Yeah,
Also.
if you have that, that's a great. Yeah, that's crack version works exactly like the latest version. Same. Okay,
Yes.
if you have that, don't disturb it. Okay.
Especially
All
for
right. So
SPSS and MOS, I think cracked versions are sufficient. We can use it.
yeah. If somebody does not have, only for them I'm telling. So
Yes,
if
sir.
somebody has it, okay. So anyway, trial version link I've WhatsApp for SPSS and MOS. I've sent it via
Yes,
WhatsApp.
I'll
Somebody,
share it, sir.
yeah, I've shared with you. So if you see, if your SPSS and MOS is working, do nothing. Use the same thing. Okay, as long as it works, it will work. Okay. Some questions are there. So first is, can you please explain the uses of that? In pattern matching, if there are negative loadings appeared, what does it indicate? Negative loadings. Okay, interesting thing. Okay, I want to. You ask the, see, if you don't ask questions, I also would not know what you are trying to tell. So I'll show you one beautiful thing. Okay. So I'll run the EFA again very quickly, and you'll see this model error. Actually, because we suppress, so we don't see. Okay. So this time I ran same pattern matrix. This is the same fit pattern matrix. Since I have not suppressed, this is the original look. Okay. What do you understand from here? Where is the loading? This is your factor loading here. This was your loading check. Okay. So it does not mean other places loadings are not there. Loadings are everywhere. Since we suppress, so we don't see. If I suppress 0.3, you cannot see any loading base less than 0.3. Okay. You see? So this is also another technique. You can load everything, bold those loadings. Okay. And then just go ahead. You see my point. So loadings are everywhere. Now, to answering your questions, negative, we are not concerned. We do not want negative loadings. Negative loading is meaningless. Okay. Negative loading is a problem. We want positive loading greater than 0.5. Also, no cross positive loading. Okay. Okay. So positive loading within that factor greater than 0.5. Then we are fine. Clear? I think you understood. Also, I drag here, not this one actually. So low, since I suppressed, so you could not see these loadings. This was loading for that, and for this factor, this quality was from here to here. Okay, now you got it. Okay, good. Also, one of the problems some people face in the SPSS, that also I'll do it. Some people say that they cannot see the, when I go here, when I click here, suppose fact, they see the full label. They don't see the names. Do you see this problem? A playful one, instead of playful one, it is showing the full sentence. Do you have this problem? Anyone? That we have to sort out. That is default options in the SPSS. Okay, if you get this problem, we can solve it. You just let me know in the chat box. If you don't, okay. So how to fix that? Ma'am, you please follow me. Whoever facing this problem, okay, how to fix that? All of us go to edit option next to file edit in the SPSS. From edit, go to the options, the last one. Edit options. Click the options. Once you click the options, you'll get a dialog box on your screen. Okay, in this dialog box, in this pop-up, what you're supposed to do? I think by default it would look like this. General variable list display labels. Please change that to display names. Display labels, change that to display names. So this is one change you have to make. There are some other changes also you have to do. From after general, first you make this change here. After that you go to output. Please go to output. In the output, you see outline labeling. There's something called, outline labeling there, and pivot table labeling. Here also have to change. You have to make it names and labels. Names and labels. And then you click OK or run. Okay. Apply, something like that. Okay. And then click OK. Got my point? So you have to make this names, labels. Names, labels, names, labels. After that only, okay, click apply, OK or OK, just OK. Okay. And then you see whether you still have that problem or not. Okay. All right. Did you get it fixed? Pushpakir and ma'am? Okay, great. All right. So with this, we conclude today's workshop. I'll see you tomorrow at 7:30, same time. Yes, ma'am?
Yes, sir. Yes, sir.
Sir, I have one
Right.
question.
Yeah, please,
Yes, go
please,
ahead.
sir.
Sir, in factor analysis, we don't have independent variable and dependent variable. Instead
No.
of that, we have a latent construct and the items, right?
No, not like that. Factor
Okay.
analysis, we treat all the variables like independent variables only. Okay, we do
All
not
variables.
all treaters like independence only. Okay, now you said
Okay.
latent. Latent is like the variable we can group. There are many different types of classification of the variables. Okay, so one such kind of classification is there where we can classify variable into two categories, where one is called observed variable that you can directly observe or directly measure, like gender,
Yes.
using one statement. And there are variables that you cannot directly measure it, okay, directly observe it. You need to ask multiple questions, multiple statements, then only you can measure it, okay, like service quality, okay, like employee satisfaction, okay. Just asking one question, you cannot measure it, right? Isn't it? So that is one classification. So mostly we use latent variables for those abstract constructs, because we do research for the abstract constructs, right? What is the point of doing research? Yeah, so that is why. So we need like latent items for that. Okay, latent variables, and we run structural equation modeling is totally based on latent constructs. Clear?
Right.
Okay.
And sir, you said that the Likert scale is an ordinal scale, but in some workshop I studied that it is considered as an interval scale also.
It doesn't matter. It
Okay.
doesn't matter. Okay, so actually, so there are two groups of scholars. One group says what is that you call ordinal, and the group says interval. Okay,
Okay.
and a lot of debates are there, but majority the learners, that they are on the side of ordinal, including myself.
Okay.
Okay,
Right.
so it doesn't matter. We treat it ordinal, interval, doesn't matter. Wouldn't change anything.
Right.
Okay.
Sir, if I am taking the variables from the literature review, so there is no need to do the EFA.
Yeah, that's what I said in the beginning. I know this debate. I've been facing this problem for a long time. So
Yes.
I am like if you are a PhD, do whatever your supervisor university tell you to do, because you're going to get the degree from there. Okay.
Yes.
If you're publishing your paper, then it depends on the journal. Okay. In India, mostly they say what you said. Okay. But this is not the universal opinion. Okay.
Right.
Universal opinion is universal opinion. You must run both. Okay. So I leave it to you. All right.
Okay. Thank you, sir.
Okay. Thank you, ma'am. All right, guys. No questions. Okay. Thank you for your time. Okay, ma'am. Can you call it off?
Yes, sir. We can call it off today, and we'll be meeting tomorrow at 7:30. I'll be sharing all the recording on your mail IDs, registered mail ID. Kindly do check it out, and please do practice. And please be ready with the database tomorrow. We'll be practicing it hands-on. We have got a very wonderful opportunity that we can practice along with sir. So please do make use of it. And for
you can bring your data. We can run it since the participants are less. And also some people can join tomorrow. We keep the link open, ma'am.
Yes, sir, it is open, sir.
Tomorrow we'll be doing structural equation modeling, starting with the MOS. Okay, so you can bring even the EFA problems also. If you have time permits, we'll run it. Okay.
Okay, sir. Okay. Thanks a lot, everyone, and thank you so much, sir. We'll meet everyone tomorrow at 7:30 in the same link. Thank you.
Okay. Thank you.
Thank you, sir.